Earlier, we discussed about the total internal reflection and critical angle. The total internal reflection means when the light ray is passing from the denser medium to the rarer medium, instant on the surface of two separating media, if the angle of incidence is more than the critical angle, the light will return into the same medium. When the total light is reflected, the phenomenon is called a total internal reflection. That will also happens in the nature also, like mirages in the deserts happen. It's a mirage is an optical illusion. It's a optical illusion. Mirage is a optical illusion. But we can see whenever the trees are inverted, whenever they behave, when they before means besides the ponds or lakes, then we can see the shadow of the tree in an inverted image, like inverted. So like that also we can see in the deserts, mirage is a optical illusion. We can see the whenever in summer days the inverted images we can form, and also the in the roads while we are going in summer days, while we are going on the road, there is also we can see some of the sparkles are over there in the road, but nothing is there. When we went to that place, then we can't see anything in that place. There is also an optical illusion. If in the deserts also we can see some in some places there is a like water will be there, we can see illusion because of sparkling somewhere like a water, a silver. So that's why here we are going to discuss about and what is mirage. This is also one of the application in nature of total internal reflection. So first of all, here in summer days, the atmosphere heat will be more. If we compare with that, the nearby the consider it's a earth, nearby the surface, the weather atmosphere with more hot than the other layers, means consider this one is the one layer and another one is layer, another one is layer. The near the surface of the earth layer will be more hotter than the another layers, so that's why it becomes its density will be decreases because of the hotness. The density of the air will be decreases and behaves like a rarer medium, and up layers of the more than the up layers of the atmosphere which are there here having the more density than this hotter layer near the surface of earth layer, they will behave like a denser mediums. So when the light is passing from the denser medium to the rarer medium more than the critical angle, then that will return to the same medium. Then also some of the sparkles we can see, but here is that the image will be formed like the image can be seen by the observer like a inverted image like this, from the like this. Always the inverted image, the image is formed due to the mirror, due to the total internal reflection will be less in size than the actual size of the tree. Here that in summer days the surface of the near the surface of the atmosphere will be more hotter, so it will behaves like a rarer medium, and the above the layers are behaves like a denser medium which is having more density than this layer, so that's why they behaves like a denser medium. Whenever the sunlight is moving from this place, then that is incident on the rarer medium, that will move from the denser medium to the rarer medium, and whenever the more angle of critical angle more than the critical angle, the incident on the layers, they will move into the same medium, means into the denser medium, then sparkles we can see, then like a mirage is something is there. In that mirage the shadow of the tree we can see in the like a inverted, like this inverted image like this. The size of the inverted image will be less than the actual size of the tree. The observer can see the inverted image like this. So due to the total internal reflection, because of in summer days, clearly don't be confused, in summer days near the layers of the surface of the earth will be hotter than the another layers, so that's why its density will be decreases, behaves like a rarer medium. Above layers are having the more density than this one, so that's why that layers behaves like a denser medium. When the light ray is passing from the denser medium to the rarer medium more than the critical angle, they will return into the same medium, and that is appears as a Parkle's like shadow, we can see the inverted image of a tree. Whatever the object is there, placed in that object, we can see that object is like inverted image, which can be seen by the observer in like this. So due to the total internal reflection, mirages are formed. Due to the total internal reflection, mirages are formed. So here is that due to the total internal reflection, mirages formed in summer days. And another in also the diamond. Diamond is also one of the example for that. One of the application will be happen in the total internal reflection application. Then the diamond cut are very sharp. Whenever the light is incident on that, then the total refractions will be formed, and due to the total internally refractions will be formed. So like this. So due to the refractions, the total light is internally reflected. So due to that, the sharp cut of the edges is there. So that's why it will moves like this in different directions. So that's why the diamond can be sparkles. Due to the total internal reflection. This is also one of the application for the total internal reflection. So after mirage, now another application of total internal reflection is a diamond. Means when a light enters into the diamonds, the diamond can be sparkles brilliantly because of due to the phenomenon of total internal reflection. Like that, here the critical, for example, if we take the shape of a diamond, diamond is cut sharply, edges having there, and whenever the light enters into the diamond, its critical angle is diamond's critical angle is 24.4 degrees. The critical angle of diamond is 24.4 degrees, and it is likely undergo the light can be undergo the likely total internal reflection whenever it is enters. Then due to that, it will be, it moves and refracted, several refractions will be happen. So in this case, the refractions will be undergoes total internal reflection. Then whenever it undergoes, it can spark brilliantly. So that's why here critical angle is 24.4 degrees, and it's a refractive index, means refractive index of the diamond will be 2.47. Refractive index of the diamond will be 2.47. Here is the which is due to the it is having the 24.4 degrees less critical angle. So that's why here the refractive index is more. So that's why critical angle is less. Due to that, whenever light enters into the diamond is subjected to cut sharply edges. That's why light likely enters into that, and due to the total internal reflection, the diamond brights means the sparkles brilliantly. Next, after knowing about the diamond, next we are going to know that optical fiber. Optical fiber means it is having the 3 layers in optical fiber, means cladding, core, like that. Now here fiber is a thin and a flexible fiber, means here whenever the total it is made up of 2 parts is there, that is one is a cladding, another one is a core. Here when the core is made up of with a transparent medium like glass or plastic, when the cladding is surrounded the core, which refractive index is less than the core, means this is a cladding and this one is the core, means the signals are passing through the core, sent by the transferred the signals through the core only. When the signals, means light rays are enters into the core, it will due to that say flexible and transparent medium is there. So it will due to the total internal reflection, the light rays can be reflect total into the reflected and emerges at the end of the tube, means here like this. Which can be seen. Due to the total internal reflection phenomenon, this is the optical fiber tubes. It is having the diameter of 10 to the power of minus 4 centimeters of diameter is there. Each fiber contains the 10 to the power of minus 4 centimeter. It's a high quality glass or plastic quartz or glass. It is made up of with glass or quartz fibers. It is used to transmit the signals, means telephone signals, to see the visualization for the doctor in the medical therapy. Also they can be used for the endoscopy like that. So here is that the optical fibers are widely using now in the medical purpose in transmitting the signals. So either due to the total internal the phenomenon of total internal reflection, optical fibers is also works, and due to the cladding, the signal can be passing through the length of the total length of the fiber, and due to the cladding it is having that less refractive index of than a core. So that's why the total light reflected internally throughout the length of the fiber, and it can be reflected through at the end of emerges at the end of which can be seen to the us. This is all used for the to send the telephone signals, and using the therapy to visualization therapy of internal organs, means endoscopy, and as well as to sparkle the lights, means decorative purpose lights. It is a small tube like that. It will be the small tube, means fibers are small tube of materials which can be used widely nowadays to transmitting the signals. So optical fibers are used in to receive or transmitting electrical signals which can be used for the light purpose, and in medically to see the internal organs used like the small pipe like that. So it is to visualize the examine for internal organs called endoscopy, and as well as used for the decorative lamps, Once again, optical fiber is a thin transparent fiber which is used it works under the phenomenon of total internal reflection, means when the light is enters into the fiber, then that totally light will be reflected due to the cladding is surrounded the core. The signal is transmitting through the core, and due to that the cladding is surrounded to the core, which is having that less refractive index than the core. So that's why the total light internally reflected in all the parts, in all the points, and it can be emerged into over the other end of the fiber. So here it is that the optical fiber which is having the diameter of 10 to the power of minus 4 centimeter. Each fiber contains the 10 to the power of minus 4 centimeters of diameter, and as well as in the medical purpose also you used a small type of pipe to visualize the internal organs for the endoscopy, means physical examiner purpose called endoscopy. As well as here the optical fibers are widely used to transmit the signals, electrical signals and telephone signals also, which can be used to the optical fibers are used, which is having that less loss of signals due to that the optical fibers are widely using nowadays. And as well as here due to that optical fibers, the very decorative purpose also, decorative lamps also, we will use the optical fibers also. Here is that. Next we are going to know that prism. Prisms used to design bend the light up to 45 degrees and 90 degrees, means prism designed to bend light to 45 degrees or 90 degrees. The light can be bent. When we take the prism This is 45 degrees and this is also 45 degrees and it is at 90 degrees right angled prism. When the light is incident on the prism in the shortest surface of one of the shortest surface, then the light will emerges, means if in the surface will be totally internal reflected with the angle of 45 degrees it is incident, then the light will emerges due to the total internal reflection, then the light will be this A, B can be traveled like this and moves here we can see this, here the display we can see this, here is a B, A inverted image can be formed. This type of right angled prisms through which can be form the inverted images are used in this periscope, and also view camera, means to see the wide angle view up to 90 degrees of wide angle view, right angled view, to see the these type of prisms used in the wide angle view cameras and also periscope also, and as well as here it is also called as viewfinder camera also, viewfinder camera. The prisms which is used to reflecting the ray of light up to 180 degrees, means that is used in binoculars, means when like this, if in case of the light is incident in like this, then the inverted image can be formed. This is AB is the image like this. Then we can see the totally 180 degrees of emerged light. Light is emerged from the face whenever means whenever it is incident on that, then like this it will comes. So here is the total prism we can get this, here it is that it can be incidents like this. So here is that whenever the light ray enters into the prism, that can be main emerges, means bends the light up to 180 degrees of which is used in the binoculars like that, and also here binoculars and as well as the total light can be right angled prism in bending of ray of light through 180 degrees, total reflection in the prism inverts the image, and such inverting prism may be used in binoculars or in a projection lanterns, otherwise this gives the inverted image. And one more thing is the bending of light up to 90 degrees, means whenever the totally reflecting prism is right angled, totally reflected prism is right angled, it is called as, the total prism is right angled is called as isosceles prism, or this prism is also called as a Poirot prism. Isosceles prism or a Poirot prism. We can call it as a isosceles prism or Poirot prism, means the total reflecting prism is also known as the right angled prism is known as a isosceles prism or a Poirot prism also. Here these are some of the loss of disadvantages of this reflecting prisms can be some of the signal loss, or means whenever the light is reflecting on the short surfaces, means short faces, there small lack of, means the disturbance will be happens because of some of the loss of light signal will be there during the reflection. So by non-reflecting surfaces, if we take non-reflecting prism, non-reflecting faces if we take, then we can reduce that loss. This is about a prism. Once again, the prisms which is designed to bend the light to 45 to 90 degrees, that right angled prisms means the reflecting prisms, total reflecting prisms are right angled, then that prisms is called as isosceles prism or Porre prism. When the light is incident on the prism, right angled prism, it can be totally internal, if the surface is totally reflected with the angle of 45 degrees which is greater than the critical angle, so then whenever the angle of incidence will be the 45 degrees means this is the normal, this will be the 45 degrees. Whenever it is 45 degrees happens, the total light will reflected internally with the 90 degrees of right angle prism. So right angled means 90 degrees of length we can be seen the image, as well as this type of prisms used in the periscope or viewfinder cameras or periscopes. So that's why here whenever the critical angle is more than this angle, then we can get the total internal reflection which can be 90 degrees of angles will be there. So that's why they are used in the periscope and viewfinder camera or view camera. And also when the light is incident on the surfaces, then in binoculars, in light projection lanterns, binoculars, whenever the light is incident on the one face and due to the total internal reflection, the images can be, without using this prism, so we can get that inverted images, which can we can get inverted images. So means reverse. If the image is like this, then we can see this images are like this reversibly, means inverted images can be formed. So that's why by using these prisms the light can be bent up to 180 degrees. So that's that type of prisms can be used in binoculars or projection lanterns. Here is that there is some disadvantage of prisms also there. Whenever the light is incidenting on the prisms by due to the reflection, whenever it is reflecting, some loss of light will be there. So that's why to reduce that loss of light, the non-reflecting prisms can be used. Non-reflecting faces can be used in this prism. These are all the applications of etc. Moreover there also. So these are the applications of total internal reflection.